Hello everyone, today we're diving into AMC 8, a super exciting math competition for middle school students. So if you are a math enthusiast, a problem solver, or someone who just enjoys a good math challenge, you're in the right place. I'm Hassan, a national math champion with years of experience training for math competitions and then later teaching others how to do the same. In this video, I'll walk you through the complete solutions of 2024 AMC 8 problems, breaking down each one step by step. So whether you're new to the world of math competitions or someone who's just looking to improve their problem solving skills, this video is going to be extremely valuable for you. If you want to explore more learning opportunities with me, check the link in the description below. I offer math courses, exam preparation guides and problem sets, and even personalized math coaching. For more math content like this, subscribe to the channel. Let's dive right into the problems. Okay, so in this problem, they want us to find the ones digit of this calculation. Now, we don't have to do the whole calculation. There is a much faster, smarter way, and that is using modular arithmetic. So if you know what modular arithmetic is, all you need to do here is take the numbers mod 10, okay? Because mod 10 gives you the last digit, right? The last digit, because mod 10 is just the remainder when divided by 10. So if we just take because we just want to find the the last digit, the ones digit of this calculation, we can just take the whole calculation mod 10. So all of these will reduce to 2, right? So the last digit is 2, so this mod 10 is 2. This is also 2, 2, 2, 2, and 2. So this will become 2 minus 2 minus 2 minus 2 minus 2 minus 2. So there are 6 2's here. And now what do we do? Now it's a really simple calculation, not like the one that we have above. So we can just go from left to right. So again, we have to remember the order of operations. It's PEMDAS, right? And in that, whenever you have only addition and subtraction, you go from left to right. That's how you do the calculation. So we go from left to right, and we get 2 minus 2, that's 0. 0 minus 2, it's negative 2. Negative 2 minus 2 is negative 4. Negative 4 minus 2, negative 6. Negative 6 minus 2 is negative 8. So remember, this whole calculation is mod 10. So what is negative 8 mod 10? Well, negative 8 mod 10 is just 2. So the answer is going to be B. Okay, so in this problem, they want us to evaluate this expression. Now, of course, you can just go ahead, take the common denominator and do that, but that's going to be long. So what we're going to do is we're going to simplify the fractions first before we, try to add them. So I see that there is a common factor of 11 here. So it's 11 times 1, 11 times 4. The same thing goes here. This is 11 times 10 and 11 times 4, and this is 11 times 4 and 11 times 100. So it becomes 4 over 1 plus 10 over 4 plus 4 over 100, which we can just write in decimal form. So that's just 4. 10 over 4 is just 5 over 2, which is 2.5, plus 4 over 100 is just 0.04. Adding these is super easy. 4 plus 2.5 is 6.5, plus 0.04 is 6.54. So the answer is C. Okay, so in this problem, they want us to find the area of this shaded region. It's made up of squares. So if you try to find the areas individually, that's going to be a bit complicated. So the easier way is to add and subtract the areas. So just imagine this. If you take the area of the big square and then subtract the area of this smaller square, we're going to get this region, right? Then we're going to add the area of this square, which will give us this whole thing, but we're going to subtract the area of this smaller square. So that will give us this region. So what would that give? What would that look like? So the biggest square we have is going to have an area of 10 squared. Then we're going to subtract 9 squared, but then we're going to add 7 squared, and then we're going to subtract 4 squared. Now again, in when it's addition and subtraction, we go from left to right. Again, we have to follow the order of operations, PEMDAS. Let's evaluate the exponents first. So that's 100 minus 81 plus 49 minus 16. We go from left to right. So 100 minus 81 is 19 plus 49 and then minus 16. 19 plus 49 is going to be 68 minus 16 is going to be 52. So the answer is E. Okay, so in this problem, Yunji adds numbers from 1 to 9, but she leaves out one number, and that makes the remaining sum to be a square number. Okay, so what did she leave out? Now, the easiest way to do that is actually first of all find the sum of these 9 numbers. Now you can just do 1 plus 2 plus 3 all the way up to 9. However, if you use the formula for the sum of integers, they're going to be much faster. So sum of integers from 1 to any number n is given by n times n plus 1 divided by 2. This formula gives you the sum of integers from 1 to the number n. Okay, for example, if it was, let's say in this case, we want to find the sum of integers from 1 to 9, so it will be 9, because n is 9 now, 9 times 9 plus 1 divided by 2, which is 9 times 10 over 2. So we simplify that, 2 times 1, 2 times 5, that's going to be 9 times 5, which is 45. Okay, so we found the sum of all the integers from 1 to 9. Now, she leaves out a number. That means the sum of the remaining 8 is going to be less than 45. Let's see, what are the square numbers less than 45 that we have. So we have 36 and then we have 25, but 25 is going to be too far, right? Because the difference is 20, and we only have digits till 9. So it has to be the square that she gets at the end has to be 36. And what's the difference? It's 9. So the number that she leaves out must be 9, so the answer is E. So in this problem, Elia rolls 2 standard dice. Standard dice is a dice with like all 6 numbers, 1, 2, 3, 4, 5, 6, with equal probability. And she notices that the product of the 2 numbers rolled is a multiple of 6. So what are the possibilities that we have? We have 6, 12, 18, 24, 30, and 36. And now she wants to know which of the following numbers in the answer choices cannot be the sum of those 2 numbers. Now, I think the easiest way to solve this problem would be by elimination. So, for example, if I can think of 2 numbers that can make this sum a sum of 9 and also multiply to give a multiple of 6, then I can eliminate that option. So for 9, I can think of easily 6 plus 3, right? 6 plus 3 is 9, and 6 times 3 is 18. So I can eliminate 9. Okay, in the same way, I can eliminate 8 because 6 and 2, right? 6 plus 2 is 8, and 6 times 2 is 12. So again, 8 can be eliminated. What about 7? Well, I can think of 4 plus 3, that makes 7, but 4 times 3 gives us 12. So again, we can eliminate 7 as well. 6 I can't think of right now. Let's go to 5. So 5, 2 numbers that add up to 5 and multiply to give, yeah, I can think of 6. So 2 times 3 is 6, and 2 plus 3 is 5. So I can eliminate 5 as well. So the only one that is left by elimination is answer choice B. So that must be the right answer. Okay, so in this problem, there are 4 different paths that they have shown us, and they want us to order them from the shortest to the longest. So let's start with the simplest one to think about, that is path P, and let's compare it with path R. So, what is the difference between P and R? It's just that, let's say between these 2 points, instead of going around the curve, we are going in a straight line. And since the shortest distance between 2 points is a straight line between them, that means that R must be shorter than P, because everywhere else is the same except for between these 2 points where we go directly in a straight line. So R must be shorter than P. Then let's compare P and S. So let's take a look at that. So P is just going around the loop, and S is we have these diagonals. So for this part, they are the same. So the orange part is exactly the same, except that in the path P, these straight lines, these are replaced by these diagonals. Now, if you just make a right angle triangle here, you'll see that since the hypotenuse of a right angle triangle is always the longest side, therefore this diagonal is gonna be longer than this straight line. So that means that P is gonna be shorter than path S because these straight lines were replaced by these two diagonals. So P is gonna be smaller than S. Now this is enough for us to find the right answer because we know that the order has to be R, P, and S, and Q is definitely gonna be bigger, longer than P, so it's also going to be here. But we can compare Q and S as well. So think of Q and S as, you see, this part is the same. These orange parts are the same, but in P we're going like this. Let's say we're going like this, but in Q instead we're going from this point all the way to the other side and then coming back. So of course this path is going to be bigger, longer than this shorter path, and that's what's happening. We're replacing these two shorter paths by these two longer paths. So Q is going to be the greatest. But anyways, even if we didn't know about Q, just R, P, and S is enough for us to figure out that the right answer is D. Okay, so in this problem, they want us to cover this 3 by 7 tiling with these tiles, this 2 by 2 tile, this 4 by 1 tile, and this 1 by 1 tile. But they want us to minimize this 1 by 1, so let's try to use as many 4 by 1 and 2 by 2 tiles as possible to cover this 3 by 7 rectangle. Now, the first observation we can make is that 3 by 7 has 21 tiles, but this 2 by 2 and 4 by 1, they always cover actually multiple of 4s. Right? They can always cover only multiples of 4, no matter which tile you use. It's going to cover, multiple of 4 squares. So the maximum that they should be able to cover should be 20. Okay, then the next one, the next possibility should be not 18 but 16. Okay, since again they always cover, since each of them cover 4 tiles at a time, if you just use these two, they should be able to cover only multiples of 4. Now, if they cover 20, that means we need to use one, 1 by 1 tile. But can we find a configuration that does that? So for the life of me, I can't find that configuration. You see, no matter how we distribute, we cannot have 5 of them here. So the maximum number of these tiles we can have is 3. And no matter how you put it, then there are 9 remaining tiles, and you can only put one square. So that's not possible. Then using these square tiles, you can only, the maximum amount you can have are 3, and then you can only have one of these longer ones. So just by doing some, trying some scenarios, we can see that this 20 doesn't seem possible, so that means they can cover 16 because uh, we do have a possible configuration for that. This is important that you are able to find a configuration that satisfies that scenario as well. So there are 5 tiles that we must cover by these 1 by 1. So even if you were confused, there are only 2 choices that you have to choose from, 1 and 5. So you try some scenarios and you can find a configuration for 5. So that's probably gonna be the right answer, and it is in this scenario. Okay, so in this problem, there's a person called Ty, and he has $2, and every day he either gains $3 or doubles the amount of money he has. And they want us to find out the different possibilities, different dollar amounts we can have on Thursday. So we're starting on Monday. So on Monday, we have $2. Now, a really efficient way to do this problem would be to just draw a tree diagram, because tree diagram is really good when you have a lot of different possibilities that you can list out. So on Tuesday, we have two possibilities. Either he gains 3, so which makes it 5, or it doubles, so it becomes 4. Now, on Wednesday, again, we have two possibilities for each of these scenarios. Either he gains 3, which makes it 8, or um, doubles, which makes it 10. And here, 4 also either gains 3, which makes it 7, or doubles, which makes it 8. Now, on Thursday, the final day, again, each of these will have two possibilities of their own. So either we gain 3, which makes it 11, or it doubles, which makes it 16. 10 also either gains 3 and becomes 13, or doubles and becomes 20. 7 gains 3 and becomes 10, or doubles and becomes 14. And 8 also gains 3 and becomes 11, or doubles and becomes 16. So these are all the possible end results we can have on Thursday, considering everything. Now, this might seem like it took a lot, but if you're doing it in the exam, you can probably get that done in like 30 seconds. So let's see how many different dollar amounts we can have. So we have 11, okay, and then we have a 10, okay, we have two 16, so then that's going to count as one, and then 13, 14. There are 6 total possible answers that we can have. So the answer is D. Okay, so this is an algebra problem with a bit of a wordplay, so we'll have to read carefully. And the trick to doing these kind of word problems is that you read each piece of information and write the expression alongside. That makes it easy, and you don't have to read the problem twice. So let's see. So they're saying Maria has red, green, and blue marbles only. She has half as many red marbles as green marbles. So red marbles are half as much as green marbles. So if you have, let's say, R number of red marbles, then green marbles must be 2R, right? Because that will make red marbles half as many as green, right? That's great. Then they're saying there are twice as many blue marbles as green marbles. So green marbles are 2R, then blue marbles must be twice as many. That will make them 4R. So the total number of marbles would be just R plus 2R plus 4R, that is 7R. Since the number of red marbles must be an integer, therefore this must be a multiple of 7. So the only answer choice that's a multiple of 7 here is 28. So that must be the right answer. Okay, so in this problem, we are starting with the CO2 level of 338 ppm. So in 1980, it's 338, and then every year it increases by 1.515. So in 1981, we add 1.515 once, and then we add 1.515 again. So since the increase is constant, this is linear. So we know that the expression for the amount after X number of years will be 338 plus 1.515 times X. Since if it's 1981, the number of years would be 1, 1981 minus 1980. So all we have to do is subtract the year number from so to subtract 1980 from the year number, and then we get X. So in our scenario, until 2030, it must be 50 years. So X is 50. So all we have to do is do this calculation, and there's an easy way to do that as well, because you can just do 1.515 times 100, which gives you 151.5. Half of that is going to be 75.75. So that's what we're going to add to 338, and it gives us 3 1, so that's 10 11, and then that's 4, so 413.75. To the nearest integer, it will be 414. So The answer is B. Okay, so in this problem, they have given us the coordinates of these 3 points, A, B, C, and they're saying that y is greater than 7, and they've given us the area of this triangle, which is 12. Now, all we have to do is use the formula for the area of a triangle, which is half base length times height. So it's reasonable to just take this as the base. So let's take this as the base. What is this length? It's going from x equals 5 to x equals 11. So that, and the y coordinate is the same, so that means it's a horizontal line. So that is 6. So using the formula for the area of a triangle, 12 equals half base is 6 times height, which is the perpendicular height, by the way. So this is the height. And this tells us that h is supposed to be 4. So that means the point C must be 4 higher than point A. So 7 plus 4 is 11. So Y must be 11, and the answer is D. Okay, so this is a simple algebra problem. Let's see. So we have 4 tanks. Let's draw those 4 tanks. 1, 2, 3, 4. So they're saying there is one more guppy in the second tank than in the first tank. So we're comparing with the first tank. Let's say that there are X number of guppies in the first tank, then there will be X plus 1 in the second tank. 1, 2, 3, 4. Okay. Then in the third tank, there are 2 more guppies than in the second tank. So it must be 2 more than X plus 1. So it will be X plus 3. And in the fourth one, there are 3 more guppies in the third tank. So it should be X plus 6. See, 1 more, 2 more, 3 more. So the total is just the sum of these, which is going to be 4x. So the sum is going to be 4x, 1, 2, 3, 4, and then 1 plus 3 is 4 plus 6 is 10. So 4x plus 10 is the total sum, and we do know the total. They told us that it's 90, so we put that equal to 90. So we get 4x equals 80, so x equals 20. So the answer must be uh, A, but that's wrong because yeah, see that was a trap. X is 20, but they asked what is the number of guppies in the fourth tank. The fourth tank has X plus 6, so that would be 20 plus 6. That's 26. I almost fell for that. So that's going to be answer E. Okay, so in this problem, a bunny is going up and down a bunch of stairs, but in one move, it can go only one up or one down. They told us that it there's a sequence of 6 hops, so there are 6 total hops: 1, 2, 3, 4, 5, 6, and we have to end up back on the ground. That means the number of ups and the number of downs has to be equal, because if they're not equal, then we are not at the starting position. So that means we must have 3 ups, 3 U's, and 3D's. Now your temptation might be to just do 6 choose 3, but that would be wrong because there are some things, some moves that are not allowed. For example, we cannot have the first move cannot be down, right? Because it's already at the ground. So that, and again, it kind of takes out a lot of those moves. So 6 choose 3 is gonna be wrong. The best way to do this, I think, will be using a tree diagram again. It's not going to take long, and it's going to take care of all the different scenarios we can have. And since it's only 6 moves, therefore it's not going to be a really big tree diagram. So let's actually do this. So the first one has to be up. There's only one choice for the first one. It cannot be down because we're already at the ground level, so the first one has to be up. Now the second move can be up or down. Now if it's down, then we're at the ground level again, so the next move has to be up again. Okay. But anyways, let's just look at this scenario. So if we do up and then up again, then we have 2 choices. We can go up or we can go down. If we go up, then we have 3 U's in a row, so the next 3 moves must be down. So that's one scenario. Okay. Now, if we go up, up, and then down, then we again have 2 choices. Either we can go up or we can go down. If we go up, then again we have three U's now in this branch. So we the next two have to be down. So this is another scenario. But if we go two up and two down, then again we are at the ground level. So the next one has to be up. And now we have three U's in this link. So the last one has to be down. That's another scenario. Now we have taken care of all of these. Let's move here. So we did up, down, now we did up. Now again, we have two scenarios. We can go up or we can go down. If we go up, then we have three U's in this link, so the next two must be down. That's another scenario. If we do up, down, then we are at the ground level again, so the next one has to be up. And the last one, of course, since we have three U's, the last one has to be down. So there are a total of 5 different scenarios we can list out using tree diagrams, and that must be the answer. So there are 5 possibilities. So the answer is B. Okay, so in this problem, we have a bunch of letters and they're connected by these arrows. These arrows represent the distance from one letter to the other. Note that the length of the arrow does not represent the distance. The numbers actually represent the distance. So we have to go from A to Z in the shortest possible way. Now there are a lot of scenarios here, but what would be the most efficient way to figure out the shortest distance? Well, what you do is you just start with any random path. I'll take the simplest one. I'll go from A to M, M to C, and C to Z. Okay, so that's one possible way to go from A to Z. And now for each segment of this path, I'll see if I can find a shorter route between those 2 points. And if I can, I'll just replace that segment with that point. So for example, here, to go from A to M, I can actually find a shorter one if I go from A to X and X to M. So I'm going to replace this with that path. See, so this is shorter than what we had before. Now, again, the same way, I can replace this 14 from M to C. I can go in a shorter way if I go from M to Y and then Y to C, because that will be 11. It was 14 previously, so that's what we have. Now, is there any other way we can make this shorter? Any of the arrows we can replace with anything else that will work. So this 5 and 10, this is smaller than 17, 2 and 6 smaller than 10. So that's it. Yeah, there is no other modification I can do to each part of the path to make it any shorter. So therefore, the total would be 5 plus 2, which is 7. 7 plus 6 plus 5, that's 18, plus 10, so that's 28. So we found a configuration that gives us 28, and that happens to be the shortest possible answer. So we know 100% that we got the right answer without any doubt. So the answer is A. Okay, so in this problem, F, L, Y, B, U, and G represent distinct digits. So that means they can be one of these: 1, 2, 3, 4, 5, 6, 7, 8, 9, yeah, and 0 as well. So this is the information that is very important. They're saying FLY is the greatest number that satisfies this equation. That means that the 6-digit number, we're multiplying that by 8, and it's still giving us a 6-digit number. Okay, and we want this to be as great as possible. So the greatest value that f can take in this scenario is 1. Like it can't be 2, because if it's 2, then it's not going to be a 6-digit number anymore when you multiply it by 8, irrespective of what these digits are. So it can be either 0 or 1. Since we're going for the greatest, so we'll take this as 1. So this is 1, this is 1. Now, the greatest L can be if you do that. So once you have this, the number is now 800. So like the minimum it will be is 800, because the number FLY is going to be 100 times 8 will be 800. That's the minimum it is right now, you know. Considering all the rest of the digits are 0. So then what is the maximum L we can have now? So since we're going to multiply that by 8 as well, so it's going to be 80080 if L was 1. If L was 2, it's going to be 160,000. and so on. If L is 3, it's going to be 240,000. That's going to be more, that's going to add up to more than 6 digits. So therefore, maximum L can be is 2. Since 1 is already taken, we're going to take L as 2. Now, the last digit, y, that's something we will have to figure out. But let's look at the other side. If f is 1 and L is 2, then b has to be 9 because right now this turns out to be around this number. Okay, 960,000. So b has to be 9 if f and l are 1 and 2. And since we are going for the greatest, again, if this works out, then we would know that this is the greatest possible. Now, what we can do is an easy way is let's try out some possibilities for y, and let's see which one actually does give us a symmetric number, symmetric answer like that. And that would probably be the only thing we can do right now. So let's see if we have 128, 128, and taking these scenarios is going to be easier than you think. So we're multiplying that. If let's say this is FLY, FLY, and we're multiplying that by 8, let's see if we get something like that. So 8 times 8 is 64. That's good so far. 8 times 2 is 16 plus 6 is 22. Now that's not okay because 2 is already used. So 8 is not a possible answer. Okay. Then we're going to try 7. So 7 times 8 is 56. 8 times 2 is 16 plus 5 is 21. That's again not going to be good because since we have every digit is appearing once, 1 is already there. So therefore, 7 is also not a possibility. Let's try 6. 6 times 8 is 48. And 8 times 2 is 16 plus 4 is 20, and 8 times 1 is 8 plus 2 is 10. So two zeros, again, not a possibility. So 6 is also gone. Let's try 5. 8 times 5 is 40. 8 times 2 is 16 plus 4 is 20. See, again, two zeros. We can't have repeated digits. So 5 is also not a possibility. So we can remove that as well. Let's do 4. So 4 times 8 is 32. Well, again, violation because we already have a 2. So 4 is also not a possibility. Let's try 3. Hopefully, that's the last option we have. Actually, we still have 0, but let's try 1, 2, 3, 1, 2, 3. So 8 times 3 is 24. 8 times 2 is 16 plus 2 is 18. And 8 times 1 is 8 plus 1 is 9. Again, 3 times 8 is 24. 18 and 9, so 9, 8, 4, 9, 4, it actually works out perfectly. So the number must be 1, 2, 3, 1, 2, 3, and the other one must be 984, 984. There is no repetition. And since we started with the maximum possible and then we moved down, that means this actually should be the maximum number that satisfies this condition. That's a way that's called extremal principle. We start with the extreme and then we keep going down so that we'll make sure that the answer we get is the maximum possible. So now we just need to add these numbers 1, 2, 3, and 984. That's 701. That's 1107. So the answer is C. Okay, so in this problem, we have a 9 by 9 grid and we're placing numbers from 1 to 81 in it. And what we're doing is we're taking the product of each row. So these are the rows. So each row and each column, and we want to see what is the least number of rows that will have a product divisible by 3. So that means the product is a multiple of 3. Now, any number is a multiple of 3 if and only if there is one of the numbers is a multiple of 3. There has to be a factor of 3 in there, and the factors of 3 are only in multiples of 3. So we have 27 multiples of 3 from 1 to 81. So we have 27, you can say, dangerous numbers, because wherever these numbers are, they will kind of eliminate that row and column, because that row or column would have a product that is going to be a multiple of 3. So wherever these numbers are, these 27 numbers, any one of these 27 numbers are, that row or column is you know gonna be eliminated. Okay. uh, so we want to minimize that, right? We want to minimize the number of rows and columns that get eliminated. Okay. So the one of the ways to do this would be to like start with smaller cases, okay, and build up, because in these combinatorial problems, if you start with smaller cases, like instead of placing 20 all 27 of those numbers, let's start with one, and then two, three, four, so you can see a pattern, you can see some underlying principles that are at work here, and then you can work your way up and generalize that to 27 numbers. So let's start with that. Let's start with one number. Let's say we had only one multiple of 3 that we had to place here. What is the minimum number of rows or columns that we will eliminate using that? So wherever you place that one number, it's gonna affect a row and a column, right? We place it here or here or here. So what I'm gonna do is I'm gonna place it in the corner, okay? And that's gonna eliminate this column and this row. Now, what about the second one? The second number, if we add one more number, if I place it in any other box here, it's gonna eliminate two more, right? A row and a column. But I can minimize that. I want to minimize it. So to minimize that, I want to place it. I want to place it in a row or a column that's already been affected. So I'm going to place it here, and that is gonna eliminate this extra row. Now, this is the interesting part. Now, for the third one, of course, we want to place it in a row and a call or a column that's already been affected to minimize its effect. However, there is one more thing that we can observe here. For the third one, if you place the third one here, okay, it's gonna eliminate this column. However, it gives us a free spot. You see, this spot right here is free. Why is that? Because if you place a number here, that row and a column is already eliminated. So this one is not gonna make a difference. So we want to maximize these kind of intersections because they give us free spots where we can place these multiples of 3 and not eliminate any rows or columns. So that's good. See, so for 4 numbers, this would be the most optimal configuration. Now, where do we place the fifth number? Again, with the idea that we want to maximize these intersections. Therefore, we are going to place it here. I mean, it doesn't really matter, like here or here. But if you place it here, that's going to give us an additional intersection. So we can place one here for free. And then now where do you place the next one? Again, if you place it on the top here, it's going to give us two new intersections. So we can place the next two here for free, right? Again, minimizing the overall damage done by these numbers, okay? Now, the next number, of course, we can place it here, and that's going to give us these two new intersections. So we can place the numbers here for free, okay? And then the next one must be at the top here because that's going to give us three new intersections. So we eliminate these and place free numbers here. So 16, we have this. Again, we can see the pattern. Again, let's just keep going just like this. We place here, eliminate these, and then place the numbers here. And then the next one must go up. So place it here. And yeah, so you see, we were able to observe this because we started with with small cases. Small cases are easier to think about, easier to deal with, and they give us insights into the problem. So for 25 numbers, this is the optimal configuration. They eliminate 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, we have 27 numbers. So where do we place the next one? Again, we just keep continue the pattern. We can place it anywhere here. So we place it here. It eliminates this row. And now we have only one more left, so we'll place it here, and that's 27 numbers. Now, how many did we get? How many rows or columns did we eliminate? It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 were eliminated, therefore the answer is D. Okay, so we have a chess problem. So I personally love chess, so this is just right up my alley. If you know chess rules, you know the king can move one step in any direction. So what they want us to do is um, they want us to find out in how many ways can we place a white king and a black king on a 3 by 3 grid such that they do not attack each other. So we have to find all the different possibilities that we can have. Now, obviously, we can't have any of the kings in the center because once a king is in the center, it attacks all the 8 squares around it. So we cannot possibly place another king. So this place is, out of bounds. Now, let's actually do it like this. We'll find out a position for white king and then find the possibilities for the black king. And if we do it in this way, in this order, then we'll make sure that we do not overcount and we don't undercount. Okay, so this is called systematic counting. Okay, it's a method that we can use to prevent overcounting and undercounting. So let's say that the white king is placed here. Then that eliminates this box and this box, and then we have one, two, three, four, five options for the black king. Now this is true for the other four corners as well. So therefore we have a total of four corners times five possibilities for the black king equals 20 total arrangements if the white king is in the corner. If the white king is, let's say, on the top edge right there, then we have to be careful. It's going to eliminate these boxes. Okay, and this is already eliminated. So we will have three possibilities only for the black king. So we have four possible edges times three possibilities for the black king. That's going to be a total of 12. So adding all of them up, we will get a total of 32 possible arrangements. The answer should be E. Okay, let's do this. So here we have three concentric circles. Concentric means their centers are overlapping. The radii are 1, 2, and 3. And basically, they're telling us that the shaded area and the white area, they are equal. And we have to figure out what this angle is, BOC. So what they want you to find out, that should be our variable. So our variable, let's call it theta. And then now in terms of theta, we're going to try to write equations. So the equation that we will write would be the white area equals the shaded area. So let's see. This is the shaded, this is the white. Let's find out those areas. So first of all, I'm going to find this white area. That's just going to be pi 1 squared, pi r squared. That's going to be pi. And then this shaded area is going to be the second largest circle, which is going to be pi 2 squared minus the smallest circle, which is pi 1 squared. So that's going to be 4 pi minus pi. That's 3 pi. Now we have this left that we need to figure out. What is that area? That's the biggest circle. That's going to be pi 3 squared minus the second largest, which is pi 2 squared, which is 9 pi minus 4 pi. That's 5 pi. 5 pi is this whole circle, but a part of it is shaded and a part of it is white, but how much of it is shaded? What fraction of it is shaded? Well, theta over 360. So the full circle is 360 and theta of it is shaded. So theta over 360, that's the fraction of 5 pi that's shaded. And then 360 minus theta, that's the rest of the angle. 360 minus theta over 360 times 5 pi, that's the white area. Now we just put them equal to each other and solve for theta. We have one equation, one variable. We should be able to solve for it. So we have 3 pi plus theta over 360 times 5 pi equals pi plus theta 360 minus theta over 360 times 5 pi. So see, all of the terms have pi in it, so I'm gonna cancel it out. So let's say divide every single term by pi, and you'll get that. And then I'm going to multiply every single term by 360 because that will get rid of the denominators, that will get rid of the fractions, and without fractions, things are much simpler. So multiply everything by 360, so we get 360 times 3 plus 5 theta equals 360 plus 5 times 360 minus theta. Okay, so let's just simplify it a bit. So let's open up this bracket. We get 360 plus 5 times 360 minus 5 theta, which is going to be 360 times 6. See, I'm not multiplying this because I can just do that calculation at the very end, because there is some simplification that will be happening here as well. Okay, now I move all the theta to the left side and it becomes 10 theta, and all the numbers to the right side, it becomes 360 times 6 minus 360 times 3, which is just 360 times 3. 360 times 3, well, 300 times 3 is 900 and 6 times 3 is 180, so that's going to be 1080. So 10 theta is 1080. That means theta is going to be 108, and therefore our answer is going to be A. So in this problem, Jordan owns 15 pairs of sneakers. 3/5 of those are red. So that means how many of them are red? Red are 3/5 of 15. So that's gonna make 9. So there are 9 red, and the rest of them are white. So 2/5, 15, that's gonna make 6. So 9 are white, and 9 are red, and 6 are white. Now 2/3 of the pairs are top, the high top tier. So the high top tier are 2/3. That's gonna make 10 of them, and then the low top would be 1/3, which is gonna be 5 of them. So you see, we have two categories, color and top tier, and then we have four possibilities, like with four possible combinations. So we will make a table out of it. That will be the easiest way to visualize this. So we have red and white, and then we have high tier and low tier. And then we do know that the red have to add up to 9, the white have to add up to 6, the high tier have to add up to 10, and the low tier have to add up to 5. So we just need to fill in these numbers so that it satisfies this table, everything in this table. So uh, the easiest way to approach this problem would be to check out the answer choices. So let's see, can this be 0? So actually, if this is 0, then this would have to be 9, because the sum is 9. But that is not possible because this sum has to be 5. So 0 is eliminated. Then we can just go one by one and check the next highest. Again, to make it easier, I'm just going to make them all have the same denominator so that it's easier to check. So this is going to be 3 over 15. This is just 4 over 15, and this is going to be 5 over 15. So the next one is 3 over 15. Let's check 3 over 15. So if this is 3 over 15, that means this is 3. If this is 3, this has to be 6, and this has to be 7. But that's not possible because this adds up to 6. So 7 is not a possibility. That means the red high cannot be 3. So we can eliminate that as well. Let's try 4. Again, 4 out of 15, so this must be 4. Then this must be 6, this must be 5, and this must be 0. It does satisfy it. Okay, all the conditions are satisfied. So that's the smallest fraction that is possible. Of course, others might also work, but this is the smallest one we have so far. So that's the answer. Okay, so in this problem we have a cube with these 8 vertices, and they want us to choose 3 of the vertices to make a triangle, and they're asking how many of these triangles are equilateral, so all the side lengths are equal, and contain P as the one of the vertices. So what we can do is we can just assume the cube to be, one by one by one. Again, that this doesn't really change the problem, but it will make it easy for us to think about it. So what are the possible lengths that we can have? Well, again, if we just go along the edge, the lengths are going to be 1, right? If we go diagonally in the same plane, the length is going to be square root of 2. And if we go diagonally up to the opposite corner, the length is going to be square root of 3. So first of all, let's see if it can be an equilateral triangle with side length 1. Okay, so if let's say this is one of the sides of the triangle, then all the other sides have to be 1 as well. So if let's say it has to be either Q or W, uh, but from P. So, but if you take Q, then this side length is going to be square root of 2, which is not equilateral. So the same thing with W. So that means we cannot have equilateral triangle of side length 1 from these vertices containing P. So 1 is, gone. Now let's take a look at triangles with side length square root of 2, which are diagonally opposite in the same plane. So let's say we take P and R. Then the other possibilities from P, which are diagonally in the same plane, are T and V. And actually, they do make equilateral triangles because from P to T is square root of 2, and T to R also square root of 2. So that's one possibility. Then P to V, again, same plane diagonally opposite, square root of 2, V to R, square root of 2. That's another possibility. And then, uh, so we have P R T, P R V, and there is another one in which we don't have an R. We have P T and V. So those are the only three possibilities we have with the side length of square root of 2. Now, there's only one point that is square root of 3 away from you. So if we choose any other point, it cannot be square root of 3 away. So we cannot have a equilateral triangle with side length of square root of 3. So that's it. This is again, we used systematic counting. We went through all the possibilities systematically and considered them one by one. So we didn't overcount, and we made sure that we did not miss any possibility at all. So there are only three possibilities, and that gives us the answer D. Okay, so in this problem, we have a bunch of frogs living in a tree, and then if they go in a shade, they turn green. If they go in the sun, they turn yellow. So we have green and yellow frogs. Okay, and that's what the question is. They want us to find the difference between the number of green and yellow frogs. So initially, they are in 3:1. So this is how you do ratio problems. You have green frogs and yellow frogs. So 3:1, that's their ratio. But if you want to use convert them into actual numbers, you can write 3x and x, right? See, they're still in 3:1, but x is a multiple that you can multiply them with to get the actual number. And see, the actual numbers we can use in calculations to make equations and stuff, but the ratios we can't. So that's why 3x and x is a good choice. Then three frogs moved to the sunny side. That means they turned yellow. So -3 from the green side, +3 to the yellow side. And then five frogs moved from the moved to the shady side. So that means -5 for the yellow and +5 for the green. So overall, now the actual numbers are 3x plus 2 and x minus 2. These are the actual numbers now after the movement. And they said that these numbers are in 4:1. So see, since we have the actual numbers, we take their ratio. So 3x plus 2 divided by x minus 2 is equal to 4/1. We can just solve this equation because one equation, one variable. Let's cross multiply. We get 3x plus 2 equals 4 times x minus 2. 3x plus 2 equals 4x minus 8. Move the x to the right side. We get 4x minus 3x, that's x. And 2 plus 8, that's 10. So x is 10. But don't rush because that's not what they asked for. They asked for the difference between the number of green frogs and yellow frogs now after the movement. So these are the numbers that we need to figure out. So x minus 2, that's going to be 10 minus 2, that's 8. So there are 8 yellow frogs, and 3 times 10 plus 2, that's going to be 32 green frogs. And their difference, 32 minus 8, is going to be 24. So the answer is E. Okay, so in this problem, we have a roll of tape that is 4 inches, that has a 4 inches of outer diameter and 2 inches of inner diameter. So this is the tape rolled. And then they're saying it has a thickness of 0.015. Okay, like the tape has a thickness of 0.015. And when it's unrolled, so when it's going to be unrolled, it's going to become a long strip, right? And that strip will have a thickness of 0.015. So that's the thickness. And then it's going to be, let's say, L inches long. However, the key idea here is if we want to find L, we need to make an equation involving L. And that is going to be comparing the areas because the total area of the cross section is going to be the same. It's unrolled or rolled into this circular thing. It's the area is going to be the same. So therefore, let's find those areas. Now, one mistake that is very easy to make is just to use these numbers to find this area, which is wrong. These are diameters, so you have to use the radii to find that area. So that area, the area of the outer circle, is going to be pi 2 squared, and the inner circle is going to be pi 1 squared. So that's going to be 4 pi minus pi, that's 3 pi. So 3 pi is the area of between these two circles. And what is the area of that unrolled tape? That's going to be 0.015 times L. So that means L must be 3 pi. So let's, because we want to give the answer in inches, let's use the approximate value of pi. That's like 3.1415, so 142 over 0.015. Now what I'm going to do is I'm going to multiply the numerator and denominator by 1,000 so that we can get rid of the decimal. That's going to become 3 times 3142 over 15. Now let's simplify this fraction. So 3 times 1, 3 times 5. Now let me just approximately divide the 33142 by 5. So that's going to be, so 5 times 600 would be 3,000. So that's going to be 600. And 5 times 20 is 100. So that's going to be 20. And then 5 times 8 is 40. So that's going to be 628 point something. So to the nearest 100 inches, it's going to be 600. And that's our answer. Okay, so in this problem, we are joining 2 points with a straight line, and the boxes that we cut through along the way, they are colored. So they want us to find, if we draw a line segment between these 2 points, how many boxes we will cut. So one key observation to make here is that these points, these points on the grid that the line passes through are very important, okay? Because we can easily determine how many boxes we're going to cut in between these whole grid points that the line passes through. And if we look at this, this is related to the slope between the 2 points. So let's find the slope between these 2 points, 0, 4, and 2, 0. The slope is going to be 4 minus 0 over 0 minus 2. So that is 4 over negative 2. That's negative 2 over 1. That means, again, as slope is rise over run, that means from the starting point we go 2 down, so the rise is negative 2, so we go 2 down and 1 across, and that's how we get the slope of negative 2 over 1. And since the slope between those two lines is going to be negative 2 over 1 throughout, that means we're going to keep going in 2 down and 1 across and keep passing through these grid points and until we reach the other point. So this is how we can figure out how many boxes it will cut by figuring out those grid points that the line is going to be passing through. And that's related to the slope. So let's find out the slope between those 2 points. So we have 5,000, 8,000, and 2,000, 3,000. So the slope is y2 minus y1 over x2 minus x1. So that's going to be 8,000 minus 3,000 over 5,000 minus 2,000. So that's going to be 5,000 over 3,000. That's 5 over 3. That means starting, let's say, imagine that this point was 2,000, 3,000. Then starting at this point, we're going to go 5 up and 3 across. That's the pattern we're going to go in. If we want to draw a line with this slope, and we know that that's the slope of the line. So 1, 2, 3, 4, 5 up, and 1, 2, 3 across. This is the grid point that it will next pass through. So let's draw a straight line between them, and let's see how many boxes it cuts. Even if you don't, like, if you just draw it roughly, you can actually figure out, which boxes it's going to cut. Because, you see, it's going to be below this point. How do I know that this line is going to be below this point? Because this line, this point will have a slope of 2, right? 2 up, 1 across, so 2. And 5 over 3 is less than 2, so it's going to be below this point. But it's going to be above this point because this point is going to have a slope of 3 over 2, that's 1.5. So 5 over 3 is greater than 1.5, so it's going to be above that. So yeah, this is how we know that this is where the line is going to pass through. That means that it's going to cut this box, this box, this box, this box, this box, this box, and this box. So between these two grid points, it's going to cut 7 boxes. Okay, so within each of those blocks, right, it's going to cut 7 boxes. So it's going to keep going like that until we reach the point 8,000, 5,000, 8,000. And an easy way to think about, how many boxes, how many of these blocks are going to be there is just thinking in one direction. So we just like every 5 we go up, we cut 7 boxes, right? So how many times are we going to go up by 5? Well, we have 8,000 minus 3,000, so 5,000 total blocks to go up. And if we go up by 5, we are going to do this 1,000 times. So we're going to have 1,000 of these blocks. And in each block, we cut 7 boxes. So it's going to be 7,000 in total. So the answer is going to be C. Okay, so in this problem, they have given us this shape that's made by two uh, 40 by the overlap of two 45, 45, 90 triangles. Because if you look at that, if you extend this triangle, you see this is 45, this is 90, this is also going to be 45. Okay, and then if you extend that side, that's going to be 45, 45, and this is also 45. Okay, so so it's the overlap of two triangles, and they have given us the total area. So let's find the area of these two triangles, or like this gray shaded region. And how do we do that? Well, whenever you have an overlap, well, you can use the uh, sets formula, right? That is going to be area of A plus area of B minus their overlap, right? That's going to give us the area of the union, right? To think of it like two sets. So let's find the area of each of those individual triangles, and then this is the overlap which we can find in terms of H, and then we'll have an equation in terms of H that we can solve. So let's first of all find the area of this pink triangle. That's a 45, 45, 90 triangle, and we know that this is 8, right? So that actually also breaks it down into another 45, 45, 90. So if you know the properties of a 45, 45, 90 triangle, right, we know that if this is x, then this is also going to be x, and this is going to be x squared of 2. That's going to be really important because if this is 8, if this, let's say, if this is 8, then this is also 8, and then this is 8 squared of 2. So this side length of this triangle is 8 squared of 2. Then this side length is also going to be 8 squared of 2. So what is the area of this triangle? That's just going to be half 8 squared of 2 times 8 squared of 2. The square root of 2 and square root of 2 will multiply to make a 2, and we'll cancel out with this, so we'll get 64. Okay, now we're going to find the area of this, let's say, green one in the exact same way as we know that this is 12. It breaks it down into another 45, 45, 90. So this is also going to be 12. And this is going to be 12 square root of 2, right? Okay, so this is 12 square root of 2. This big green triangle is also 45, 45, 90. So this is also going to be 12 square root of 2. So the area, again, half base times height, is going to be half 12 square root of 2 times 12 square root of 2. The square root of 2 and square root of 2 will multiply to give you 2, which will cancel out with this. So the answer is going to be 144. So the area of those individual triangles is going to be 64 plus 144, but we have to subtract the overlap. This is the overlap. This orange triangle, that is their overlap, and we just subtract it once so that we can get the area of the union. So What does that triangle look like? That triangle has a height of h, and since this is 45 as well, I mean, if this is 90, then these two are parallel, right? So if these two are parallel, then this is 45 degrees. And if these two are parallel, then this is 45 degrees as well. Then this is 90. So this is a 45, 45, 90 triangle. If we drop a perpendicular, it breaks it down to two more 45, 45, 90 triangles in the exact same way as we did for the green and pink triangle. If this is H, this is also H, this is also H. So the area of this triangle is going to be half 2h times h, which is just h squared. So we do 64 plus 144 minus h squared, and that should give us the area that they gave us, which is 183. Let's simplify this and let's see what we get. So we get 64 plus 144 is 208 minus h squared is equal to 183. H squared is 208 minus 183, which turns out to be 25. That means h is equal to 5, and that is the answer, B. Okay, so the hard one. Let's see. In this problem, we have four rows of three seats in an airplane, and we have already boarded eight passengers distributed randomly on these seats. And then they're saying that a married couple comes next, and they want to find the probability that there will be two adjacent seats in the same row for the couple. What is the probability of that? Now, first off, whenever they talk about probability, you know that there is only one formula that is at play. So probability is always going to be successful possibilities over total possibilities. Successful possibilities over total number of possibilities. Okay, that is always going to work out. Probability is always going to be this formula. So let's figure out what are the total number of possibilities. So if you just figure out the total number and the successful, you will be able to solve the problem. So what are the total number of possibilities that we have here? Well, let's say that eight passengers have already boarded, so four seats are left behind. So the total possibilities would be all possible four seats that can be left behind. So that will be just 12 choose 4, right? So all possible combinations of four seats left behind will be 12 choose 4, which is going to be 12 factorial over 8 factorial times 4 factorial, which is 12, 11, 10, 9 over 4, 3, 2, 1. This will be like that, and that will be 495. So 11 times 5 is 55. 55 times 9 is going to be 495. So we calculated the total number of possibilities that we can have. Now, within those possibilities, how many of the possibilities will be successful? So those will be the possibilities in which we will be able to have, adjacent seats. Right? So let's actually go through them systematically. We're going to count that using systematic counting. So again, the same idea, systematic counting. Okay, so let's go through them one by one. One scenario is for those four possible seats that are empty, is that there are three seats in the same row that are empty, and then one extra seat. How many possible ways can this happen? So for the row with the three seats empty, there are four ways to choose that row. And then the remaining one seat can be any one of the remaining nine, right? So there will be 4 times 9, that is 36 total possibilities, right? So let's say this row was chosen, and then the last seat can be any one of these 9, right? And each of them will give you a uh, different possibility. So therefore, it's going to be um, you know 9 for each one of those rows. So 4 times 9, 36. Okay, now that's one. Now what else? We can have 2 and 2, so 2 in one row and 2 in another row, right? So how many ways can that happen? So let's say the first one, we have 4 possible rows to choose the first group, and then there are 2 possible ways in within each row for those 2 seats, like this and or like this. So that's 4 times 2, that's 8, times Then there are three remaining rows, and in each of those rows, again, two possible ways to choose choose the pair, adjacent pair. Okay, this is the possibility we're considering is two adjacent seats in two different rows. Okay, now the thing with that is, and that is a really important point, that the answer would be 8 times 6, which is 48. But that's not the final answer because we can even switch those two groups, right? Switching these two groups is not going to create a new possibility, right? But the way we counted it, it actually considered them to be separate, right? So, but they all the seats are the same. There is no distinction. So the order does not matter. Therefore, we will divide the final answer by 2. So there are 24 possible ways to have two adjacent seats in two different rows. Okay, this is very important. This divide by 2. Without that, you'll keep getting the wrong answer. Okay, next up, what other possibility do we have? We have a possibility that we have two adjacent seats in a row, and then in another row, the two seats are non-adjacent, but they're still in the same row. How many possibilities do we have for this? Well, we have four possibilities for the first row, for the first group, and then within those, we have two possibilities, so two more possibilities for the two adjacent seats, right? Within each row, we have two possibilities for the adjacent seats. So they're going to be a total of 8 possibilities times. Now we have 3 possibilities for choosing the other row. And within each row, we have only one possibility for the two seats that are non-adjacent. So that's going to be 3. So 8 times 3, that's 24 more possibilities. Now there's only one more possibility left that we need to consider, and that's a big one. And that is we have two seats adjacent in a row, and then the two other seats are non-adjacent. Sorry, the two other seats are in different rows. And that's going to be a big one. So let's see. Again, similarly, first of all, we choose the row with the two adjacent seats. There are 4 possible rows, and in each row, there are 2 possibilities for adjacent seats. So that's 8 possibilities times. Now, this is important. See, let's say this is a row having 2 adjacent seats. Now, from the remaining 6 rows, we have to choose a row. So that's um, 3 possibilities for a row, and then within each row, now we have 3 more possibilities for the single seat. So that's 3 times 3. And then we have 2 rows remaining, so we have 2. And then within each of those 2 rows, so we have 2 possibilities for the last row, and then within each of those 2 rows, we have 3 possibilities. However, again, in the same way, these 2 seats, the way we counted this last part, we considered them to be different, but they're not different. They're indistinguishable. So even if we switch them, it's not going to create a new possibility. So this answer that we get, we're going to divide that by 2. So that's going to be 9 times 6, which is 54. 54 divided by 2, so that's going to be 27. So this is 8 times 27. Okay, and that's going to be the total number of possibilities for this last scenario. And there is no other scenario, right? There is no other scenario we can have in which we have 2 adjacent seats. So let's see. So 8 times 27, how much is that? So 27, 8, 56, 60, and 216. So that's 216. Okay. So let's add all of them up, and that will be our successful number of possibilities. So we do 36, 24, 24, and 216. Let's see, 10 and 10, 20, 0, 2, and then that's 5 and 5, 10, 1, and that's going to be 3. So it's 300 over 4. So 300, that's 300, right? So 10, 10, 10, so 0, 1, so 3, yeah, 300. So the successful number of possibilities are 300 here, and the total number of possibilities are 495. Let's simplify that now. So we can divide them by 5. That's going to be 60, and that's going to be 99. You can divide them by 3. That's going to be 20, and that's going to be 33. And we can't divide them any further. So the final answer is going to be 20 over 33. So the answer is going to be C. If you want to explore more learning opportunities with me, check the link in the description below. I offer math courses, exam preparation guides and problem sets, and even personalized math coaching. For more math content like this, subscribe to the channel.